Hi everyone. Today we're going to study basic rules of derivative. Let's have the first rule. This is about derivative of a constant. If k is a constant, then d over dx of k equals 0. Let us see some examples. This is example 1. Y equals 5. So we have y prime equals 0. Second example, y equals negative 10. This is another constant, so we say that dy over dx equals 0. In here, we used another notation of derivative. Example 3, f of x equals pi. This pi is considered a constant, so we say that f prime of x equals 0. These are the answers for these examples. Rule number 2. This is derivative of a power function. We have d over dx of x raised to n. And this is equal to n times x raised to the power n minus 1, provided that n is not equal to 0. Let us see some examples. This is example 1. Y equals x cubed. So the derivative is y prime equals, the power 3 here comes down as coefficient, then multiplied by x, and this x is now raised to the power 3 minus 1. Simplifying further, the power 3 minus 1 becomes 2. So the derivative here is y prime equals 3x squared. Example 2, y equals 1 over x raised to 7. Let us show that this fraction has a term with negative exponent. So we have now x raised to negative 7. Let us now apply the rule of derivative. So our y prime here equals negative 7. That is the power that will come down here as coefficient times x raised to negative 7 minus 1. So in the exponent, the negative 7 minus 1 becomes negative 8. Putting this negative exponent into positive exponent, so we have our final answer as y prime equals negative 7 over x raised to 8. Example 3, y equals square root of x. Let us rewrite this function into a fractional exponent. So we have x raised to 1/2. And then let us apply the rule of the power function. So the y prime equals 1/2 times x raised to 1/2 minus 1. In our exponent, this 1/2 minus 1 becomes negative 1/2. And then let us rationalize the negative exponent. It becomes 1 all over 2 times x raised to positive 1/2. Let us return the fractional exponent into radical form. So we have our answer to be 1 over 2 times the square root of x. These are the answers for the given examples. Rule number 3. Multiplication of a constant by a function. If k is a constant, then d over dx of k times f. This f is a function. So this is equal to k times the derivative of the function. Example 1, we have f of x equals 2x raised to 5. So the derivative here is 2 times the derivative of this x raised to 5. And that is equal to 5x raised to 4. Then we will multiply the constant 2 with the coefficient 5. So the final answer is 10x raised to 4. Example 2, y equals 5x raised to negative 3. This is equal to dy over dx equals 5 times negative 3 times x raised to negative 4. We multiply 5 times negative 3 and our final answer is negative 15x raised to negative 4. These are the answers for the given examples. Rule number 4 is about addition rule. So we have d over dx of the two functions f plus g. So we have here the derivative of f plus the derivative of g. Let's see this example 1. Y equals 3x raised to 5 minus 2x cubed. So we're going to take the derivative of each of the function, just like this. So we have y prime equals the derivative of 3x raised to 5 minus the derivative of 2x cubed. So we have here y prime equals 15x raised to 4 minus 6x squared. Example 2, y equals 10x plus 7. Again, we're going to take the derivative of 10x plus derivative of 7. For the derivative of 10x, we have 10 times 1 times x raised to the power 1 minus 1 plus the derivative of 7, which is a constant, is 0. Simplifying further, we have now 10 times x raised to 0. This x raised to 0 is simply 1. So 10 times 1 is equal to 10. These are the answers for the given examples. Today, we're going to study product rule of derivative. Let f and g be two differentiable functions. The derivative of the product of f and g, denoted by d over dx of the product f times g. This is equal to f times d over dx of g plus g times d over dx of f. Or simply we write f times g prime plus g times f prime. Let us see this example 1. Find the derivative of y equals, the first function is x squared plus 1 times the second function x cubed plus 2x. For our solution, let us write the formula of the product rule. And then, let us assign the first function to be the f, while g for the second function. And for the derivative of this y, we will have this y prime equals, we copy the f or the first function, that is the x squared plus 1, multiplied by the derivative of the second function. So this is the g prime, and we have here 3x squared plus 2. Then plus, we write the g, that is the second function. So we have here the x cubed plus 2x. Then multiply by the derivative of the first function. So we have here 2x. Simplifying the product of each group, we have now 3x raised to 4 plus 2x squared plus 3x squared plus 2 plus the product of the second group here, we have the 2x raised to 4 plus 4x squared. Let us remove the grouping symbol and combine similar terms. So we have now y prime equals 5x raised to 4 plus 9x squared plus 2. This is the derivative of the given function here. We have another solution to consider, and that is to simplify first the function. We will get the product of this function, so we have now y equals x raised to 5 plus 2x cubed plus x cubed plus 2x. We can combine the two terms in the middle, so we have y equals x raised to 5 plus 3x cubed plus 2x. And from here, let us get the derivative. So we have now y prime equals 5x raised to 4 plus 9x squared plus 2. We can see here that our answer is the same with our product rule formula. Now, for example 2, find the derivative of y equals 3 minus x squared times the quantity x cubed minus x plus 1. For our solution, let us write the formula of the product rule. And let us assign the f for that first function and g for the second function. And for our derivative, we write like this. The first function here is the f, that is the 3 minus x squared, then multiplied by the derivative of the second function, that is g prime. So we have here 3x squared minus 1, then plus, the g is the second function, so we have the x cubed minus x plus 1 times the derivative of the first function f, that is f prime. So we write here negative 2x. Let us simplify the products respectively. So we have y prime equals 9x squared minus 3 minus 3x raised to 4 plus x squared. Then plus, the second group will be negative 2x raised to 4 plus 2x squared minus 2x. Let us remove the grouping symbol and combine similar terms. So we have y prime equals negative 5x raised to 4 plus 12x squared minus 2x minus 3. This is our final answer. Today, we're going to study quotient rule of derivative. Let f and g be two differentiable functions. The derivative of the quotient of f and g, denoted by d over dx of the fraction f over g. The answer is a fraction where the denominator is the square of g. And in our numerator, we have two products. The first product is g times f prime minus the second product is f times g prime, where the function g of x is not equal to 0. Let us see this example 1. Find the derivative of y equals the fraction x squared plus 1 all over x cubed plus 2x. For our solution, let us write the formula of quotient rule. And then we take note that the function in the numerator is the f, while the denominator is the g. So writing now the derivative, let us begin with squaring our denominator. So we write here the square of the quantity x cubed plus 2x. And then let's begin with writing the first product. And this is g times f prime. So we write here x cubed plus 2x, that is the g, times the derivative of f. So we have the derivative of x squared plus 1, we write here 2x. Then minus the second product is f times g prime. So we write here the f is the x squared plus 1 times g prime, the derivative of x cubed plus 2x. So we write here 3x squared plus 2. Let us simplify the corresponding products of our numerator. So the first group will be 2x raised to 4 plus 4x squared. Then minus the second product is 3x raised to 4 plus 2x squared plus 3x squared plus 2. Let us remove the grouping symbols of the numerator, so we will have 2x raised to 4 plus 4x squared minus 3x raised to 4 minus 5x squared minus 2. Now let us combine similar terms in our numerator. So we have negative x raised to 4 minus x squared minus 2. And in the denominator, it will just be the same. The square of the quantity x cubed plus 2x. This is our derivative. This is the final answer. Let's have example 2. Find the derivative of y equals 2x plus 5 all over 3x minus 2. For our solution, let us write again the formula of quotient rule. And we take note that our numerator is the function f while the denominator is the function g. Writing now our derivative, let us begin with squaring our denominator. So we write here the square of 3x minus 2. Next, let us write the first product here, g times f prime. So we copy the denominator, that is the 3x minus 2, times the derivative of 2x plus 5. So we write here 2. Then minus the second product, f times g prime. F is our numerator, so we have 2x plus 5 times g prime, the derivative of 3x minus 2. So we write here 3. Let us simplify the corresponding products of the numerator. So we have the first product to be 6x minus 4 minus the second product is now 6x plus 15. Let us remove the grouping symbols of our numerator. So we have now 6x minus 4 minus 6x minus 15. Combining similar terms in our numerator, we have the final answer to be y prime equals negative 19 all over the square of 3x minus 2. This is the final answer. Let us have example 3. Find the derivative of the function y equals 2x minus 1 all over 1 minus 2x. For our solution, let us write again the quotient rule. Let us assign the f to be the numerator and the g the denominator. Our y prime now is equal to, the denominator is the square of g. So we have 1 minus 2x, and this quantity is squared. Then, let us write the first product, g times f prime. So we write here 1 minus 2x, that is the g, times f prime, the derivative of 2x minus 1, that is 2, minus the second product is f times g prime. So we write 2x minus 1, that is the f, times g prime, the derivative of 1 minus 2x. So we write here negative 2. Simplifying the corresponding products of the numerator, we have now 2 minus 4x minus negative 4x plus 2. Removing the grouping symbol of the numerator, we have now 2 minus 4x plus 4x minus 2. Let us combine similar terms of our numerator. It is now simplified into 0 all over the same denominator, square of the quantity 1 minus 2x. So the final answer for y prime is simply 0. Now let us consider another solution here, and that is to simplify the function first. Observing our function here, we can rewrite our denominator, and from here we can see that we can cancel out the numerator and the denominator respectively. So the function here is now simplified into negative 1. And now we are ready to take the derivative of this function. So the derivative of a constant is simply 0. We can see here that our answer here is the same with our answer in the first solution. This is our final answer. Today we're going to study higher order derivative. Suppose that you have a function, say f of x. Then the derivative would be f prime of x. We can consider f prime of x as a new function and find its derivative also. That is finding d over dx of f prime of x. This symbol here can be simplified into this symbol, and we read this as f double prime of x. And this is now considered to be the second derivative. We can show also that the second derivative is d over dx of d over dx of f of x. And simplifying this, we may show that d square over dx square of f of x. Or if the function is given as y, this is one of the most popular notation for second derivative, and this is d square y all over dx square. Using the second derivative of f, we can find the third derivative, the fourth derivative, and so on. Successive derivatives can be denoted as follows. Given the function f of x, f prime of x equals d over dx of f of x. This is the first derivative. F double prime of x is equal to d over dx of d over dx of f of x. Simplifying this, we can write d square all over dx square of f of x. And this notation is for the second derivative. We have now f triple prime of x, and this is equal to the derivative of the second derivative. So we see here we have d over dx of d square over dx square of f of x. We simplify this into d cube all over dx cube of f of x. This is the third derivative. In general, we write f raised to a power n inside a parenthesis of x is equal to d with power n all over dx raised to power n of f of x. And this is the nth derivative. Let us see this example 1. Find y triple prime of y equals 2x raised to 4 minus 3x plus 7. The y triple prime here means the third derivative. For our solution, Let us begin with the first derivative. So y prime equals this 4 multiplied by 2 becomes 8 multiplied by x with the power 4 minus 1. So we see here power 3. So 8x cubed minus the derivative of 3x is here 3. So minus 3 plus derivative of the constant 7 is 0. So we will not write anymore. Therefore, the first derivative is equal to 8x cubed minus 3. Next, for the second derivative, that is y double prime equals this 3 multiplied by 8 becomes 24 times x raised to the power 3 minus 1. So we see here 2. So y double prime is equal to 24x squared. The derivative of the constant is 0, so we will not write anymore. For the third derivative, that is the y triple prime is equal to this power 2 multiplied by 24, it becomes 48 times x raised to the power 2 minus 1. So we simply put here x. So y triple prime is equal to 48x. This is our final answer. Let us see example 2. Find d square y over dx squared. So this is about second derivative of the function y equals x raised to 5 at the point x equals 2. Let's begin with finding the first derivative. So we have dy over dx equals the power 5 comes down here as coefficient. So we have here 5x raised to the power 5 minus 1, which is 4. So the first derivative is equal to 5x raised to 4. For the second derivative, we will have now this symbol. So we have 4 times 5 is equal to 20 times x raised to the power 4 minus 1. So we have here 3. So the second derivative is 20x cubed. For our problem here, we can write this in symbol as d squared over dx squared of the function x raised to 5. And we put a line here, and the subscript is that x equals 2. This is about the second derivative, and we are going to evaluate it when x is equal to 2. So this is equal to the second derivative value, 20x cubed. Now, let us substitute the value of x is equal to 2. So we have 20 times 2 raised to 3. And this 2 cubed will give us 8. And 8 times 20 is 160. This is our final answer. Example 3. Find the second derivative of y equals x squared plus x plus 8. We use the first derivative symbol as y prime of x. So we take derivative of each of the terms here. Let's start with the x squared. So we have 2 times x raised to 2 minus 1 plus derivative of x is 1 plus derivative of 8 is 0. Simplifying further, we have for this first term that is now 2 times x that is raised to power 1
plus we copy this one, no need to write the 0 here. So with exponent 1, we can simplify further as 2x plus 1. This is the first derivative. Second derivative notation, we use the y double prime of x. So we take derivative of each of these terms. So derivative of 2x is 1 times 2, then multiplied by x, that is raised to 1 minus 1, plus derivative of 1 is 0. Simplifying further, we have 2x raised to 0. Then we simplify this x raised to 0 as 1. 2 times 1 is 2. This is the final answer. Example 4. Find third derivative. This is the notation. Given y equals 5x squared minus 3x raised to 5. Let's start with the first derivative, and this is the notation, dy over dx. Let us now differentiate each of the terms of the function. For the first term, the derivative is 10x minus 15x raised to 4. Second derivative, and this is the notation. We take the derivative of each of these terms. So the 10x here becomes 10, and this negative 15x raised to 4 becomes negative 60x raised to 3. We know that we multiply 4 by negative 15. That's why we have here negative 60. And the 4, we subtract by 1. So it becomes 3 in here. Now the third derivative. Let us now take derivative of each of these two terms. Derivative of 10 is 0, and derivative of negative 60x cubed is now negative 180 times x squared. This 3 we multiply by negative 60, that's why we get this negative 180. And this power 3 minus 1 becomes 2. This is the final answer. Example 5. Find the second derivative given y equals 3x raised to negative 3 minus 1 over x. Let us rewrite the given function. With this fraction, we can write this as x raised to negative 1. And then let us now start with the first derivative, dy over dx. Derivative of the first term will be the negative 3 times 3 times x, that is raised to negative 3, then minus 1, minus derivative of the second term. So we have the negative 1 comes down times x raised to negative 1 minus 1. We simplify the first term as negative 9 times x raised to negative 4. And then the second term, negative of negative 1 is now positive. Then we have the x raised to negative 1 minus 1. So we have here negative 2 as exponent. This is the first derivative. Then let's go to the second derivative. This is the notation. Let's take derivative of each of these terms. For the first term, we have the negative 4 times negative 9 times x, that is raised to negative 4 minus 1, plus negative 2 multiplied by x, that is raised to negative 2 minus 1. We simplify the first term, that will be positive 36x raised to negative 5. Then minus 2 times x raised to negative 3. This is the second derivative.
Today, we're going to study derivative of trigonometric functions. The derivative of trigonometric functions are We wrote the first two, d over dx of sine x. This is equal to cosine x. Second, d over dx of cosine x equals negative sine x. The second two are d over dx of tangent x equals secant square x. The fourth one, d over dx of cotangent x equals negative cosecant square x. The last two, we have d over dx of secant x. This is equal to secant x times tangent x. The last is d over dx of cosecant x. This is equal to negative cosecant x times cotangent x. Take note that trigonometric identities are helpful in simplifying derivative. Some important but not limited to identities are tangent x equals the fraction sine x over cosine x. Cotangent x is equal to 1 over tangent x. And this is equal to the reciprocal of this fraction. So we write here cosine x over sine x. Next, we have cosecant x equals 1 over sine x. Secant x equals 1 over cosine x. Sine square x plus cosine square x equals 1. This is one of the most popular identities. Tangent square x plus 1 equals secant square x. 1 plus cotangent square x equals cosecant square x.
Example 1. Find the derivative of y equals negative 10x plus 3 cosine x. We have y prime equals this value. Derivative of negative 10x is negative 10. Derivative of 3 cosine x, we copy the constant 3. Then derivative of cosine x is negative sine x. Then we simplify. So y prime equals negative 10 minus 3 sine x.
Example 2. Find f prime of x of f of x equals x squared cotangent x. For our solution, let us observe that our function here is a product of two functions. The first function is x squared. The second function is cotangent x. So we are going to use two formulas here. The first is the product rule. So we write here d over dx of the product f times g. This is equal to f times g prime plus g times f prime. Next is the derivative of cotangent x. So we have d over dx of cotangent x equals negative cosecant square x. For the computation of derivative, we write now f prime of x equals, we copy this x squared here, times, we are going to show that we will take the derivative of cotangent x later. So we write cotangent x prime plus, we copy this cotangent x, it is here now, times the derivative of the first function, x squared. So we see the prime symbol here. Let us now simplify the derivatives. So we have x squared times the derivative of cotangent x is negative cosecant square x plus, we copy again this cotangent x times the derivative of x squared, which is 2x. Now let us simplify the corresponding products. So we write f prime of x equals negative x squared cosecant square x plus 2x cotangent x. Take note that the x here is a polynomial function, while the x in here is the angle of the cotangent. So we cannot put them together. This is our final answer. Example 3. Find dy over dx of y equals the fraction 2 times cosine x all over 1 plus sine x. For our solution, let us observe that our function here is a quotient. So we write the quotient rule. D over dx of the fraction f over g equals g times f prime minus f times g prime all over g squared. Next formula is the derivative of cosine x. So we write here d over dx of cosine x. This is equal to negative sine x. Next is the derivative of this sine x. So d over dx of sine x equals cosine x. We are now ready to write the solution for the derivative. So we have dy over dx equals, we will apply the quotient rule. First, by squaring the denominator. 1 plus sine x is now squared here. And then, in the numerator, we're going to write 1 plus sine x, that is the g function, times the quantity, which is the derivative of the numerator. So this is 2 cosine x prime. Then minus, we will copy the numerator, 2 cosine x times the derivative of the denominator, 1 plus sine x. That symbol here again shows derivative. Let us now simplify the corresponding derivatives into like this. We will copy everything except that our derivative here of 2 cosine x now becomes, we put the constant outside 2 and then take the derivative of cosine x, and that is this negative sine x. Then this negative 2 cosine x we copy here, then we take the derivative of this binomial. The derivative of 1 is 0, that is a constant, plus the derivative of sine x is cosine x. Now simplifying the product of the numerator, we have now negative 2 sine x minus 2 sine square x for this group. Then minus, for this group here, it is simplified into 2 cosine square x all over the same denominator. Please observe in the numerator that we have a common factor, and that is the negative 2. We can pull out the negative 2, so we have this negative 2 times the quantity sine x plus sine square x plus cosine square x all over the same denominator. Take note that the sum of sine square x plus cosine square x is an identity, and that is equal to 1. So we can change these two into a simple value, which is 1. So we have now negative 2 times the quantity sine x plus 1. Please observe also that this sine x plus 1 is the same with 1 plus sine x. So we can cancel this binomial in the numerator, and we will subtract 1 in the power of our denominator. So our answer now becomes negative 2 all over the quantity 1 plus sine x. This is our final answer.
Example 4. Find the derivative of y equals negative 10x plus 3 cosine x. We have here a function which is the sum of two functions. We will take the derivative now. We're going to have the derivative of each of the functions. So derivative of negative 10x is negative 10 plus derivative of 3 cosine x. We copy the constant 3, then we take derivative of cosine x, that is negative sine x. Simply we combine the positive 3 with the negative sine x. So finally we have negative 10 minus 3 sine x. Example 5. Find the derivative of y equals secant x times cosecant x. We can observe that the function is a product. So we will apply the product rule. This is our formula. So we assign secant x to be the first function, that will be u, and the cosecant x, that will be the v. Now we use the notation y prime of x. Let's begin taking the derivative. So we have now secant x, we copy the first function, times derivative of the second function. Derivative of cosecant x is negative cosecant x cotangent x, plus we copy the second function, cosecant x, times derivative of the first function. The derivative of secant x is secant x tangent x. And from here, we can simplify further. Let us express each of the functions in terms of sine or cosine. For the first group, we put the negative sign in front, and then the secant x becomes 1 over cosine x. This cosecant x becomes 1 over sine x. Cotangent x becomes cosine x over sine x, plus the second group. Cosecant x becomes 1 over sine x. The secant x becomes 1 over cosine x. Tangent x becomes sine x over cosine x. We can simplify further. Look at the first group. We can cancel the cosine x respectively. On the second group, we can cancel the sine x respectively. And then we can simplify by multiplying corresponding values. In the first group, we have 1 over the product sine x times sine x. So for the first group, we have this negative of 1 over sine square x, plus the second group, that is 1 over cosine x times cosine x, and that will be cosine square x. Then we simplify again this fraction into its corresponding identity. The 1 over sine square x, we can now write as cosecant square x. So the first term will be negative of cosecant square x, plus this 1 over cosine square x is equivalent to secant square x. Example 6. Find the derivative of y equals 1 plus cosecant x all over 1 minus cosecant x. We can observe that the function is a quotient. So we will use the quotient rule. We assign the numerator to be the u, the denominator to be the v. Let's begin with taking derivative. First, in our fraction, we copy our denominator v, we copy it here with power 2. And then, we copy this value of v, the 1 minus cosecant x, up here, multiplied by the derivative of our numerator. Derivative of 1 is 0, derivative of cosecant x will be negative cosecant x cotangent x, then minus. We copy the numerator, and it is here, times the derivative of the denominator. Derivative of 1 is 0, minus derivative of cosecant x, we will have this negative cosecant x cotangent x. Let us now simplify the numerator. This negative cosecant x cotangent x we multiply to 1 also to the negative cosecant x. So that will be negative cosecant x cotangent x plus cosecant square x cotangent x minus. Look at the second group here. There is negative of negative. So this value here is positive multiplied by 1 and also to the cosecant x. So we will get cosecant x cotangent x plus cosecant square x cotangent x. Now, let us remove the grouping symbols respectively. In the first group, directly we can remove the grouping symbol. In the second group, because of this negative sign, we need to change the sign of all the terms inside the second group. So we have like this. Now simplifying further, let us combine like terms. Look at this positive cosecant square x cotangent x. There is negative cosecant square x cotangent x. When we combine, it becomes 0, or we cancel it out. The negative cosecant x cotangent x, there is also negative cosecant x cotangent x. So we can combine them. So finally, negative 2 cosecant x cotangent x all over the square of the quantity 1 minus cosecant x.
Today, we're going to study derivative of inverse trigonometric functions. First, let us have a review about inverse function. If f of x is defined from a to b, such that f of x equals y for all x an element of a, where it is a bijective function. Bijective means the function is one-to-one and onto. Then there exists the inverse function f raised to negative 1 power. This is the symbol for inverse, defined from b to a, such that f inverse of y is equal to x for all y an element of b. Let us also review about inverse trigonometric functions. For the trigonometric function, let's say y equals sine x. If we want to get the angle x, we compute for x equals sine inverse of y. And it follows that the inverse function becomes y equals sine inverse of x. In other books, you will see y equals arc sine of x. Let us study now derivative of inverse trigonometric functions. Let us write the formula starting with d over dx of sine inverse of x. This is equal to 1 over the square root of the quantity 1 minus x squared. By chain rule, the formula becomes like this, where u is a function of x. Second, d over dx of cosine inverse of x. This is equal to negative 1 all over the square root of the quantity 1 minus x squared. By chain rule, the formula becomes like this. Take note that there is a similarity in the derivative of sine inverse and cosine inverse. The difference is the negative sign in the cosine inverse. Third formula, derivative of tangent inverse of x. This is equal to 1 all over 1 plus x squared. By chain rule, the formula becomes like this. Fourth formula is d over dx of cotangent inverse of x. This is equal to negative 1 all over 1 plus x squared. By chain rule, the formula becomes like this. Take note also that there is a similarity between the formula of derivatives for tangent inverse and cotangent inverse. The difference is the negative sign for the cotangent inverse. Next is the derivative for secant inverse x. This is equal to 1 all over the absolute value of x times the square root of the quantity x squared minus 1. By chain rule, the formula becomes like this. Sixth formula, the derivative of cosecant inverse of x. This is equal to negative 1 all over the absolute value of x times the square root of the quantity x squared minus 1. By chain rule, the formula becomes like this. In here, take note of the similarity of the formula of derivatives for secant inverse and cosecant inverse. The only difference is the negative sign for the cosecant inverse formula.
Example 1. Find the derivative of y equals x tan inverse x. We can see that the function is a product. So we will use the product rule. We take x to be the u and tan inverse to be the v. So for the derivative, that would be we copy the x times derivative of tan inverse x, and that is 1 over 1 plus x squared. Then plus, we copy the tan inverse x times derivative of x, which is 1. Then we simplify. X times this fraction will be x over 1 plus x squared plus tan inverse x.
Example 2. Find dy over dx for y equals x sine inverse x plus x squared cosecant inverse x plus 3 tangent x. For our solution, take note that there are some functions here which are products of two functions. This first function and the second function here. So we will apply the product formula. So dy over dx will be like this. For this function, the derivative now is we take the x times the derivative of the second function, plus we copy the second function times the derivative of the first function, then plus the derivative of this function is we copy the x squared times the derivative of the second function here, plus we copy that second function times the derivative of the first function, then plus the derivative of 3 tangent x is now 3 secant square x. Let us simplify this line by taking the derivatives respectively. So we have the derivative of sine inverse x is here, that is equal to 1 all over the square root of the quantity 1 minus x squared. The derivative of x is 1. The derivative of cosecant inverse x is negative 1 all over absolute value of x times the square root of the quantity x squared minus 1. The derivative of x squared is 2x. Simplifying further, this line now becomes like this. In the next line, we will simply remove the grouping symbol, and we will have this as our final answer.
Example 4. Find the derivative of y equals x squared cosine inverse x. Note that the function is a product, so we will use the product rule. We assign the x squared to be the u and the v is the cosine inverse x. Now the derivative, that will be, we copy the u, that is the x squared, times derivative of the cosine inverse x. So we write here negative 1 over the square root of the quantity 1 minus x squared, plus we copy the v, the cosine inverse x, it's here, times the derivative of u, that is x squared becomes 2x. Now simplifying the first group plus the second group, we have now negative x squared over the square root of the quantity 1 minus x squared for the first group, plus 2x times the cosine inverse of x. Take note that in the second group, this 2x must not be multiplied with the x in here. So we put this 2x in front of the cosine inverse function. Example 5. Find the derivative of y equals sine inverse x all over 2x minus 3. Note that the function is a quotient or fraction. Therefore, we are going to use the quotient rule. Let's start taking the derivative. First, we copy this 2x minus 3, we put as denominator with power 2. Then, the 2x minus 3, we will copy on top, to be multiplied by the derivative of sine inverse x, and that is 1 over the square root of 1 minus x squared. Then minus, we copy the sine inverse x multiplied by derivative of the denominator, so that is 2. Now we simplify our numerator. So we have 2x minus 3 all over the square root of 1 minus x squared minus 2 sine inverse x. All over, the denominator here will just be same. Now let us simplify our numerator. Let us combine this fraction minus this 2 sine inverse x. What we're going to do is to multiply the 2 sine inverse x by a fraction. whose numerator and denominator is the same with this denominator here. So we have like this. And then we can see that the two fractions are like. Now we can combine them. So we have 2x minus 3 minus 2 sine inverse x times the square root of 1 minus x squared all over the square root of 1 minus x squared all over the square of the quantity 2x minus 3. At this point, we can simplify this complex fraction into like this, meaning this numerator as a fraction we copy as is, multiplied by this denominator that we flipped upside down. So we have this 1 over the square of 2x minus 3. Then simply we multiply the two fractions. So in the denominator, we can simply put together the two functions. So it becomes like this. This is the final answer.
Today we're going to study derivative of exponential functions. First, let us define exponential function. The function y equals e raised to x is called exponential function with base e, where e is equal to 2.718281828 and so on, and this is an irrational number. We will study now the derivative of exponential functions. Let us write the formula. The first one is d over dx of e raised to x, and this is equal to e raised to x. It means whatever the function we see here, we will just copy here. In general, when we have d over dx of e raised to an exponent which is a function of x, the derivative is equal to e raised to f of x times f prime of x. Letter B, d over dx of a raised to x. This a is a value that is greater than 0. This is now equal to a raised to x times ln of a. This ln is natural logarithm. In general, d over dx of a raised to f of x, this is equal to a raised to f of x times ln a times f prime of x. Let's see example 1. Find dy over dx if y equals e raised to the function x cubed. For our solution, we write the general equation for the exponential function where base is e. This is our formula. Now, let us write the derivative like this. First, we copy the function itself, e raised to x cubed, times d over dx of x cubed. Simplifying the derivative here, we have 3x squared. Rewriting the derivative in such a way that the constant is in front. So our final answer is 3x squared e raised to x cubed. Example 2. Find the derivative of y equals 5 raised to x sine x. For our solution, we will take the derivative of this, but we should remember three things. Number one, the product rule. We can see here that our function is a product of two functions. The first function is 5 raised to x. The second function is sine x. Second, remember the derivative of sine x. And the third, remember the derivative of a raised to x. In this case, the a is equal to 5. So with regard to our product rule, let us now write the derivative. So we have 5 raised to x times d over dx of sine x, plus we copy that sine x times d over dx of 5 raised to x. Let us copy again this line and then let us simplify the respective derivative. So the derivative of sine x will be cosine x. The derivative of 5 raised to x will be 5 raised to x times ln of 5. We can see that we have two groups here and there is common, and that is the 5 raised to x, and we can factor that out. So our final answer is 5 raised to x times the quantity cosine x plus ln of 5 times sine x. Example 3. Find the second derivative of y equals x raised to 5 e raised to 3x. In this problem, we can see that we need a product formula. Let us now solve the first derivative. So dy over dx equals x raised to 5 times the derivative of e raised to 3x plus that e raised to 3x times the derivative of x raised to 5. Let us take now the derivatives respectively. So the derivative of e raised to 3x will be e raised to 3x times the derivative of 3x. And then, in here, the derivative of x raised to 5 will be 5x raised to 4. Now, the derivative of 3x will be 3. When we simplify this line, the final answer for the first derivative will be 3x raised to 5 e raised to 3x plus 5x raised to 4 e raised to 3x. For the second derivative, we're going to take the derivative of this dy over dx. And in here, we have two terms that are both products of two functions. So taking the second derivative, we keep the constant outside. So we'll have d square y all over dx square is equal to the constant 3 is outside times the quantity x raised to 5 times derivative of e raised to 3x plus e raised to 3x times derivative of x raised to 5. So this is for the first group here, plus the derivative of this. So we write here the constant 5 outside, and then x raised to 4 times derivative of e raised to 3x plus e raised to 3x times derivative of x raised to 4. Let us now take the derivative respectively. In this case, we will have this 3e raised to 3x, derivative of x raised to 5 will be 5x raised to 4. The derivative of e raised to 3x will be 3e raised to 3x. The derivative of x raised to 4 will be 4x cubed. Let us now simplify this line by multiplying the respective constants inside. So we will have this 9x raised to 5 e raised to 3x plus 15x raised to 4 e raised to 3x. The first two terms here correspond to this group, plus 15x raised to 4 e raised to 3x plus 20x cubed e raised to 3x. The last two terms here correspond to this group. On this line, please observe that the middle terms here are similar terms, that we can combine them. So we have 30x raised to 4 e raised to 3x for the combination of these two terms. On this line, please observe that there is a common factor. And the common is x cubed and e raised to 3x. Factoring out that common term, we have x cubed e raised to 3x times the quantity 9x squared plus 30x plus 20. This is our final answer. Today we're going to study derivative of logarithmic functions. Let us first define logarithmic functions. The function y equals log of x to base b, where b is not equal to 1 and b is a positive constant, is called a logarithmic function. On the other hand, the function y equals natural log of x. In symbol, we write ln x, is a logarithmic function with base e. Let us study now the derivative of logarithmic functions. For our formula, let's start with d over dx, or the derivative of log of x to base b. This is equal to 1 over x times the natural log of b, or ln b. In general, we have d over dx of log of u to the base b, where u here is a function of x. This is equal to 1 all over u times ln of b, multiplied by du over dx. Letter B formula, d over dx of ln of x. This is equal to 1 over x. In general, we write d over dx of ln of u. Again, this u is a function of x. This is equal to 1 over u times du over dx. Let us see this example 1. Find the derivative of y equals log of the function 2x plus 5 to base 7. For our solution, here is the formula for the derivative of log of u. Take note that our u here is the function 2x plus 5. Using this formula, we will now write y prime, that is the derivative, is equal to 1 all over the function 2x plus 5, that is the u, times ln of 7. 7 here is the b. Then times d over dx of the function 2x plus 5. Simplifying now this derivative here, we have the answer as 2. Let us multiply this 2 with this fraction. We'll just put this 2 as numerator. And this is our final answer. Example 2. Find the derivative of y equals e raised to 2x times ln of x squared. For our solution, we take note that we have a product here of two functions. The first function is this e raised to 2x. The second function is ln of x squared. We will use the product formula here. So our dy over dx, or the derivative, is equal to e raised to 2x times the derivative of the second function, plus we copy the second function times the derivative of the first function. On the next line, we're going to copy everything, and this time we will simplify the respective derivative. So the derivative of ln x squared is 1 over x squared times the derivative of x squared. In here, the derivative of e raised to 2x is e raised to 2x times the derivative of 2x. We will copy this line in the next step, but we will evaluate the derivatives respectively. So the derivative of x squared will be 2x. The derivative here of 2x is now 2. Now look at this portion of the first group. We can see that x can be cancelled with 1x of the denominator here. Here we go. And then, in the two big groups here, we can observe that there is common among them. And the common is the 2 times e raised to 2x. Factoring the common, we have 2e raised to 2x times the quantity 1 over x plus ln of x squared. This is our final answer. Example 3. Find the second derivative of y equals x squared times ln x. For our solution, we take note that here we have a product of two functions again. The first function is x squared. The second function is ln of x. So let us take now the first derivative. We have y prime equals x squared, that is the first function, and then multiplied by the derivative of the second function. Plus, we copy here the second function times the derivative of the first function. On the next line, we will evaluate the derivatives respectively. The derivative of ln x is 1 over x. The derivative of x squared is 2x. In this group, we can see that we can cancel this x in the denominator and one of the x in this expression. Here we go. So in the next step, we have now the y prime, or the first derivative, equals x plus 2x ln x. Now let us take the second derivative. So we will write y double prime. This is equal to the derivative of x is 1, then plus. Let us write the constant outside, and we will take derivative for x and ln x. So we copy first the x here and take the derivative of ln x. Plus, we copy the second function ln x times the derivative of that x. Simplifying now the derivatives respectively, the derivative of ln x is now 1 over x. The derivative of x is 1. We can see in this portion that x times 1 over x, we can cancel those x. So it will be equal to 1. Now let us multiply this constant 2 in all the terms inside the grouping symbol. So we have 1 plus 2 plus 2 ln x. This number 1 plus 2 can be combined together. So y double prime is equal to 3 plus 2 ln x. This is our final answer. Today, we're going to study equations of tangent line and normal line. Given the function y equals f of x, and this is the curve. Now, we have a tangent line that intersects the curve at the point x sub 1, y sub 1. The derivative of the function at a specific point x sub 1, y sub 1 is the slope of the tangent line to the curve at that point, which was denoted by m. It means in symbol we write m equals f prime of x at the point x sub 1, y sub 1. Therefore, for this tangent line, the equation is y minus y sub 1 equals m times the quantity x minus x sub 1. Moreover, the slope of the perpendicular line, this is the line, and we call this normal line, to the curve is negative 1 over m, where m is the slope of the tangent line at the point x sub 1, y sub 1. In other words, the slope of the normal line is the negative reciprocal of the slope of the tangent line. And the equation of the normal line is this: y minus y sub 1 equals negative 1 over m times the quantity x minus x sub 1. Let us see this example. Find the equations of the tangent line and normal line to the curve y equals 4 minus x squared at the point negative 1, 3. For our solution, the step 1 is find the slope m. So we write m equals f prime of x at the point x sub 1, y sub 1. So first, we're going to take the derivative of the curve. So we write here y prime is equal to the derivative of the constant 4 is 0, so we will not write anymore. The derivative of negative x squared is negative 2x. Next, let us substitute the value negative 1 to the x. And this negative 1 is the x coordinate of the given point. So we write m equals f prime of x at the point x sub 1, y sub 1 is equal to this negative 2x. So we write negative 2 times the x, now substituted by negative 1. So negative 2 times negative 1 is positive 2. This is the slope of the curve at the given point. This is also the slope of the tangent line at the given point. So for step 2, let us now find the equation of tangent line. Our standard form is y minus y sub 1 equals m times the quantity x minus x sub 1. Substituting the corresponding values, we have now y minus 3 is equal to, the m here becomes 2, times the quantity x minus our x sub 1 is the negative 1. Simplifying the right side, the negative times negative becomes positive. So we have positive 1 here. Simplifying again the right side, we multiply the number 2 to the x and to the 1 respectively. So we have now 2x plus 2 in the right side. Now, this negative 3 here, let us transpose to the right. From negative, it becomes positive. And then, let us combine this positive 2 and the positive 3. So we have our final answer to be y equals 2x plus 5. This is the equation of the tangent line. Now for step 3, let us find the equation of normal line. So this is our standard form, and on this part, we are going to write the negative reciprocal of the slope here. Substituting the corresponding values, we have now y minus y sub 1 becomes 3 equals, the slope here now becomes negative 1 over 2 times the quantity x minus negative 1. Simplifying further, let us cross multiply the denominator 2 to the left side. So we have now 2 times the quantity y minus 3 equals negative 1 times the quantity x plus 1. Simplifying both sides, we have now 2y minus 6 equals negative x minus 1. Since we have here a negative x, let us transpose all terms of the right side going to the left. Of course, we know that the signs must be changed respectively. So we have now x plus 2y minus 6 plus 1 equals 0. Let us combine this negative 6 plus 1, so we have negative 5. So we have now our final answer for the equation of normal line. X plus 2y minus 5 equals 0. These are the answers for the tangent line, and the normal line.
Example 2. Find the equation of the tangent line to the graph of the function y equals 2 square root of x at the point 1, 2. Step 1. Let us find the slope, which is m. First, let us take the derivative. In our function here, it is given in radical. Let us rewrite this function into x with rational exponent. So we have y equals 2x raised to 1/2. Then we take the derivative. So we have 2 times 1/2 times x, that is raised to the power 1/2 minus 1. And then we can simplify, we can cancel this 2 with the denominator 2. And for the x, with negative 1/2 power. We can rationalize the negative exponent. So we have 1 over x raised to positive 1/2. And in the denominator, we return the radical. So we have 1 over square root of x. Next step, let us substitute the x value to get m, or to get the slope. So we have m equals 1 over square root of 1. Remember that the x value means the x coordinate of the point. Then we simplify further. The square root of 1 will be 1, so 1 divided by 1 is 1. This is the value of the slope. Now step 2. The equation of tangent line, we're going to use our point slope form. Let us substitute the corresponding values. Y sub 1 is the y coordinate here. The m is the value from step 1, and x sub 1 is our x coordinate. So we have y minus 2 equals 1 times the quantity x minus 1. We simplify the right side to be x minus 1, and then this negative 2 here we transpose to the right. Negative 2 becomes positive 2, where we combine with negative 1. So finally, we have y equals x plus 1. This is the equation of tangent line. Example 3. Find the equation of the line tangent to the graph of f of x equals 3x squared plus 4x plus 1 at x equals 0. Step 1, let us find the slope. Meaning, at first, we will take the derivative of the function. So we have f prime of x equals derivative of 3x squared is 6x. Derivative of 4x is plus 4. Derivative of 1 is 0, so we will not write anymore. Next, we're going to substitute the x value to get m. So m equals 6x becomes 6 times 0 plus 4. Remember that 0 here comes from the given value. Now we simplify further. 6 times 0 is 0, or simply we say that we cancel this. So m equals 4. For the step 2, let us first find the y coordinate. Meaning, let us take the f of 0. Again, the 0 here comes from the given. So when we evaluate, f of 0 is 3 times 0 squared plus 4 times 0 plus 1. Simplifying further, 0 squared is 0 and 0 times 3 is 0. Or simply we say that we can cancel this term. 4 times 0 is also 0, and we say that we can cancel this term also. So finally, f of 0 is 1. Now step 3, we write now the equation of tangent line using our point slope form. Y sub 1 here is the value of step 2. M is the value from step 1. x of 1 is the value from the given. So we have now y minus 1 equals 4 times the quantity x minus 0. We can simplify the right side. 4 times x is 4x. 4 times 0 is 0. So we simplify further by putting this negative 1 on the right side. So from negative, it becomes positive 1. Finally, the equation of tangent line is y equals 4x plus 1.